Okay, exercise 145, page 365. I'm going to have a look at question 4 and use the data in this question to form a frequency distribution so that I can then produce a frequency polygon, a cumulative frequency curve, from which I'll get the median and talk about the other quartiles that might be involved there, and also a histogram at the end. So the first thing we're asked to do in this question is to form a frequency distribution having 8 class intervals, about 8 class intervals with unequal class interval size. And the reason why it's a good idea to have unequal class interval sizes is because if you look at the data, well, it ranges from 3 right up to 47, but it's not evenly distributed by any means. There's lots of data in the 20s and then only a few less than 10, between 10 and 20, say this one, and also a few in the 30s and 1 or 2 in the 40s. So in other words, the data is not evenly distributed. So it's a good idea to have unequal class intervals so we can focus in on the data in the 20s, so smaller class intervals within there, and then we can afford to have bigger class intervals when we've got a small amount of data in the outliers, in the outlying groups. So I'm going to try and produce columns about 8 or 9 intervals and make it so that I can have nice whole numbers as the midpoints in the groups and then have smaller class intervals in the 20s. And I've chosen to go from 0 to 10, from 11 to 19, 20 to 22, 23 to 25, 26 to 28, 29 to 31, 32 to 40, and 41 to 50. We're talking about whole numbers here, so I just need to make sure, for example, that at 28, 29, there's going to be nothing in between 28 and 29 here, so I don't need to worry about defining the exact point in the middle between those two. However, I will need to worry about that when I come to look at the histogram, because that needs to end on the same point, and the next group start on the same point. So, but I've chosen these so that the midpoints, so if we let the next column represent the midpoint, and I'm going to need that for the frequency polygon, it's a nice whole number. So 0 to 10, midpoint is 5, 11 to 19, the midpoint is 15, 20 to 22, 21, and so on. So nice whole numbers for the midpoints. So that's why I chose those particular groups. 31 to 40, 8, so it's to be 36, 41 to 50. This particular one, well, because it's the final group, I can use the midpoint 45, say, to represent that group. So those are the midpoints. Now I need the frequency. So to get the frequency, I'm going to need a tally. So I can go through my data and actually decide, using tally marks, which particular group each piece of data goes into. So then I can get the frequency. Now I can plot the frequency polygon, because that will be frequency against the midpoint. Just putting points on and joining them with a straight line. To be able to calculate the cumulative frequency curve, I'm going to need to find the cumulative frequency, so I can then find the cumulative frequency. And then I'm going to need to plot the histogram, so I'm going to need the lower class boundary and the upper class boundary. Lower class boundary and the upper class boundary. So I'll put both of those in that same column, so that I can then calculate what the width is, and then from that I can work out the frequency density, which is the width divided by, the frequency divided by the width. So those are the columns I've produced. You could now carry on and try and give you this question, but I will go through the solution below bit by bit. So looking at our data then, so 28 is the first piece of data. So as I go through, to make sure I don't make any mistakes, and also so that if people distract me, I'll know where I am, I'm going to cross off each one as I put it in. So 28 goes in the 26 to 28 group. So put that a tally mark in there. The next one, 22, goes in the 20 to 22 group, and so on. So I'm just going to pause this video and complete the putting the data in. Okay, so I've now completed the tally marks to produce the frequency. So now I add up my tally marks. I've got 3 in the 0 to 10 group. Using the 5-bar gate, 5 plus 2 is 7, 12, 11, 10, 2, 4, and 1. And I would add those up to check that they come to 50, which is the number of pieces of data I have. So I know I haven't made a mistake at that point. So now I could go ahead and plot the frequency polygon. So here I put a graph on in the video here. You obviously use graph paper. I'm going to put frequency up the side. So I need to go up to 12 for the frequency because that's the highest frequency. And along the bottom, I need to plot the midpoints for each group. And the highest midpoint is going to be 45, so I need to make sure I've got to at least 45. And then literally I just put the points on. So if we go back to the table, the first value I had, a frequency of 3, midpoint 5. So frequency of 3 at midpoint 5, so 5 will be that here, so about here somewhere. So the first data point. And then go back, next date 15, frequency 7. 15, frequency 7. Here. And so on. Carry on, put the data points on. So now I have the data points on there. To form the frequency polygon, I just join those with a straight line. So using this straight line tool here, I can do that on here. So from there to there, and from there to there, and finally down to there, and then up. So you can form the frequency polygon. Now I want to go back to the table, and I want to produce the cumulative frequency ogive, or cumulative frequency curve. So to do that, I need the cumulative frequency. That means I add up the frequency as I'm going along. So for the first cumulative frequency, 3 plus 7 is 10. 10 plus the next frequency is 12 is 22, 33, 43, 45, 49, and 50. So obviously we should end up with 50 for the final one. Now I want to know what the upper class boundary is for this value. So I'm going to plot the highest point in the group. So I'm going to plot 10. What I'm saying is there are 3 pieces of data. So the frequency is 3 up to 10 of my pieces of data. Then up to 19, there are 10 pieces of data at 19 or less. What about up to 22? Well, there are 22 pieces of data that have a value of 22 or less, and so on. So that's why the cumulative frequency is important, and it must go with the highest value in the group. So I'm going to plot the highest value in the group against the cumulative frequency to get the cumulative frequency ogive. The highest value in the group against the cumulative frequency. So now I plot group values along the bottom from 0 up to the highest value, which is 50, and then cumulative frequency on the y-axis, and then I put my values on there. So see if you can have a go at it. I'll plot the graph as well. Okay, so the first piece of data that's going to go on is I'm going to plot cumulative frequency of 3 goes up to a maximum of 10, so on my on the x-axis. So I'm going along to 10 on the x-axis and up to a cumulative frequency of 3 on my y-axis. So 25, about 3 is right here. Not a brilliant scale for this. The next piece of data, I'm going from 19 is the maximum value in the next group, and that goes up to a cumulative frequency of 10. So I'm going to go to 19 on the x-axis and 10 on the y-axis. So up to 19 on the x-axis and 10 on the y-axis takes me to here, and so on. Carrying on putting the points on. So now put the data points on. Now we need to join these up with a smooth curve in between the points. So we can go from here up and around through the data points as well as we can to get this familiar S shape, this cumulative frequency ogive, it's sometimes called, that represents the data here. So now I can use this data because I've plotted cumulative frequency against value or data point, x if you like. Then I can ask myself questions. Because I've gone up to the maximum value in the group, I can say how many people, or how many pieces of data rather, have a value of 25 or less. So I can go to 25 on my graph, which is here, and then go up to where this meets the line, and then across to get a value. How many people, around about 35 bits of data rather, have a value of 25 or less? How many bits of data have 40 or less, and going up and across? What's the value for the 30th piece of data? So if I went, or say the 25th piece of data, so I can go to the 25th piece of data and across and down to get that value. 25th piece of data across and down to get that value, and so on. So I can use the cumulative frequency curve to get information. So the median is easy from the cumulative frequency curve. The median is the middle piece of data. Well, if I've got 50 pieces of data, then the 25th piece of data is the median. So I can go from the 25th piece of data across and down, and that tells me the value of the median. Taken from the scale, we can actually estimate an actual value for the median. So estimating around about 22 from this piece of data. Because we've got the cumulative frequency up the y-axis like this, we can actually get other information like quartiles. Some people are interested in what's the highest, the lowest quarter, in other words, the quarter of the data. So that's 12.5, 50 bits of data, 12.5. So what is the 12.5 value? We go to 12.5 on here, 10 about here somewhere, and we can say, what is this? The 3/4 mark. So what's that? 37 is around about here, so we can go from there to there. So we can actually now say between those 2 points is half the data, isn't it? Between the 25% of the data and 75% of the data is half the data roughly. So half the data lies between these 2 points, which is something that might well be interesting to us. So we can use the cumulative frequency to get information. You're going to be asked on the BTEC course to find a cumulative frequency curve, or plot a cumulative frequency curve, and use that to find the median. So the key point is to remember that what goes along the x-axis is the highest value in the group. Okay, so finally we're going to use this data to plot a histogram. So to get the histogram, I need to know what is the boundary. What's the boundary between this piece of data and this piece of data? 10.5. Between 10 and 11 is 10.5. So the lower class boundary from this group is 0. The upper class boundary is going to be 10.5. So this goes from 0 to 10.5. The next group starts at 10.5, which must be the case, and goes up to a halfway point between 19 and 20, which is 19.5. The next one starts at 19.5 and goes up to the midpoint between 22 and 23, which is 22.5, and so on. So now we have the lower class boundary and upper class boundary. What we do is, to find the width, we subtract the upper class boundary, the lower class boundary from the upper class boundary. So 10.5 minus 0, 10.5. That's the width of this group. 19.5 minus 10.5, 9.0, and so on. So we can work out the width of each group. So you can see, having put the widths in, that now we can see that between the 20 and 30 we've got quite small group sizes, width of 3, but then the outliers have much bigger group widths. Now we need to calculate the frequency density, which is the frequency. So in this case, the first column will be 3 divided by 10.5. The second one will be 7 divided by 9.0, and so on. So now I'm just going to complete this last column by dividing the frequency by the class width in each case. So now we have the frequency density, and what we need to do now is plot the histogram. So we start our histogram. They're going to be bars that will start at the lower class boundary. So the first particular bar will start at 0, finish at 10.5, and go up to a height of 0.3 on the frequency density y-axis. The next group will start at 10.5, go up to 19.5, and go up to a height of 0.7. The next column will start at 19.5 on the x-axis, go up to 22.5 on the x-axis, and up to a height of 4, and so on. So let's have a go at plotting the histogram. I'll put the histogram on a graph for you. So here I'm plotting frequency density up the y-axis and x along the y-axis, my group x along the y-axis. So let's start putting the bars on. So the first bar is going to start at 0, as we were saying, go up to 10.5 on the x-axis and up to a height of 0.3. It's going to start at 0, go up to 10.5, so starting at 0, go up to 10.5, which is going to be around about here, and up to a height of 0.3. So 0.3 will be about here. So my first bar will be here. My second bar starts at 10.5. It must start at the same point as the previous one finished, goes up to 19.5 and up to a height of 0.7. So 10.5 to 19.5 is about here, up to 0.7, which is going to be around about here. So something like this, and so on. Now complete putting the bars on. So here is our final histogram plotted. The beauty of the histogram is that we can see that the spread of the data is pretty well in the middle. However, this middle group here, the frequency in this middle group, is given by the area of the bar. So in other words, if we look at these different groups, we can see actually the area of each of these little rectangles in this histogram, they're not too far apart in the middle there. So in a bar chart, the height of the column represents the frequency, so that can be disproportionate. And so a histogram is used so that the area represents the size of the sample, which is in some ways more representative of the data. So there's your final histogram plotted.